So this number right here, this is going to affect the amplitude. So instead of going up 1 and down 1, I'm going to go up 3 and down 3. Other than that, everything else is going to be the same besides my range. My range is obviously going to be negative 3 because I've stretched it. So amplitude, which this is your A, little a, that is going to stretch it. Okay, so when we are doing different things to our functions, we're always going to start off with the basic values for whatever trig function that we use. So up here, we had our sine, and we use these values. I'm just recreating those values down here. This is going to be like our jumping off point. And so this is going to affect not the x values, but the y values. It's going to stretch that y value. And so what I'm going to do is I'm going to take all these y values and I'm going to multiply them by 3. So I'm going to create a new row for my y value. So I'm going to say 0, 3, 0, negative 3, 0. So when I create my graph, use the same x values, nothing to the x value. But now, instead of going up to 1, I'm now going to go up to 3. So it stretches it up to 3 and it stretches it down to negative 3. So it should look, my graphs are not even, but it would be like 3 times higher and 3 times lower. Okay, so this is what the graph for that looks like. Notice the period is still the same. So period is like, start looking at your x values. So when that's affected, those x values are going to change. It's just still 2 pi. Set notation for domain is the same. And see if you can do, or both of them for domain is the same. See if you can do set notation for range. Okay, so your values should look like this. And so this is everything you need for a graph. Okay, so I want you to try to do cosine on your own, or this function on your own, which is a cosine function. So kind of be aware of that. So you're going to start off with the cosine values, and you're going to multiply all your y values by negative 2. So go ahead and try that. Okay, so I have everything set up, and the only thing I have not done is multiply this by negative 2. So even though our amplitude is 2, that's a distance, we're still going to take whatever that is, positive or negative, and multiply it, because that negative is going to flip the graph. So my new y value is going to be negative 2, 0, positive 2, 0, negative 2. So instead of it looking like that, it's going to look like that. Okay, and my graph looks like that. So make sure you have all this for this function. So notice the placement of this 3. Instead of out here, that would affect my amplitude. This is going to affect my period. So I'm going to show you what happens here. Okay, so I want to show you this sine graph. So notice that, like, hopefully you can see that look. As I make the amplitude bigger, so we've talked about amplitude, notice how our graph gets bigger, but our unit circle, instead of radius being 1, it gets bigger or smaller depending on the number. So like 3, then our radius would be 3. But now, let's go back to normal. Our wavelength, that is going to be what we're talking about now. So it's going to compress it. So instead of having, so if we have the 3, instead of having the look of one graph as it goes around the circle, it's going to have the look of 3 graphs as it goes around the circle. So what I'm saying here is this function, even though we're not really going to show it in our final graph, what's going on is it's going like 1, 2, 3 times around in the time that it would usually take to just do it once. So what we're going to focus on for our like our final graph is just that piece right there. So you're not going to see what's going on in the background, but so instead of having our last value to 2 pi is going to be 2 pi over 3. I just wanted to kind of have you keep that in mind. Okay, so let's kind of start with the xy. I think that'd be easier. So we're always going to start off with the same values for whatever trig function this is. So sine is going to be 0, pi over 2, pi, 3 pi over 2, 2 pi. Y value 0, 1, 0, 0. So the quicker you memorize this, the better. Okay, now this 3 in that position, that's going to affect our x values. And x values, remember, just like x values in a regular function, they're usually always opposite. So, so this is a 3. You would think that we're multiplying by 3, but no, no, no. We are doing the opposite. We're going to divide by 3. So I'm going to make a new row down here with my new values. So whenever you're dividing, you just multiply on the bottom. So pi over 6, pi over 3. So I have, let's think about this. I have 3 pi over 6, which simplifies to pi over 2, and 2 pi over 3. So this is my x values, and these are my y values. So I'm going to go ahead and graph. Okay, so your graph should look something like this. Notice, even though I've done something pretty significant to my graph, it still looks the same as that very first graph that we talked about here. But that's not going to change. Okay, I want you to go through and see if you can answer everything in here. Okay, these should be your answers for everything there. So go ahead and see if you can go down here and do this cosine function. Notice we have an amplitude here, and we have something that affects our period there. So this is what your graph should look like. Notice I divided my x's by 5 and I multiplied my y's by -1. So that affected the graph as far as the y values. I just flipped it and that condensed it by a factor of 5. Okay, now see if you can answer the top part. So one mistake that's made is like when it's flipped, sometimes people kind of have a hard time understanding that with interval notation. It really doesn't affect like the interval notation or set notation. It's the same. Your bottom is -1, your top is 2, or sorry, +1. So that is it, guys.